Okay, everyone. So this is another good question about geometry. So let's look into what we have. Okay. So radius is given of this inscribed circle, and that's 6. And what's the centimeter of AB? Okay, that's my hypotenuse of the right triangle. Okay. So the question is given like circle and the triangle, and I usually say whenever you see a circle with some different figures, find the center and connect with intersection, which usually helps. Okay, if I connect this with each intersection, which is, I'm gonna say these guys are my tangency point. Okay, so, and when you connect this center to this tangency point, I'm gonna call maybe same name. So let's say this is D, this is E. So the angle right here is gonna be 90, because this is a straight line, so this line radius will divide this 182 equal pieces, and that would be 90, and this will be 90 as well. If you are curious about why that's 90, so this is like common sense based on like our guess, but we have a really nice uh, proof as well, explanation, but it's going to take forever for now, so let's not dive into that. So now we know the radius is given 6, so that looks like 6, and this is 6 as well. So you do have a 390s, which makes this guy as 90 as well, and that will be a square, because this is like 90s, with this side and this side is same, so opposite side should be same as well. So these guys are 6 as well. Okay, and what we want is just the AB, right? I'll do this question like two ways. The first one is just kind of splitting my figure into some pieces. Okay, and then we know this is also 6. So my first approach, like if you take this point and connect with each vert vertices, you are gonna get 3 triangles, right? At least, not more than 3, but let's focus on only those 3s. So this guy is one triangle, okay, and then maybe this guy is the another one, and then this guy is the another one. So split into different region that you can maybe handle easily might be useful. Okay, this is something, and we have a 60 degrees and we have a 90. That means the angle A is 30 degrees. If you are given some information that never used, so it's actually good to use those. So, but before we do, maybe I should remind 30, 60, 90 triangle. Okay, so let me have something right here. So whenever you have a 30, 60, 90 triangle, which is one of our special triangles, so let's assume this is 60, this is 30, we have a really nice relation. Okay, so the smaller angle is 30 degrees, opposite is, let's say, is x. The hypotenuse, which is the opposite to 90 degrees, is gonna be twice as big. And the third leg, I mean, yeah, second leg or the third side is gonna be smaller leg times √3. Again, if you don't know this relation, it's good to take a look at the special right triangle. This is really important. So based on this, I have 60, I have 30. So if I call like maybe this side, okay, x for the BD, okay, if this is x, then I can actually let's use the whole piece as x. Okay, I'm gonna do this next time. So let's say this is x, which is the opposite of 30 degrees in my a larger triangle. The hypotenuse will be twice as big, and the other leg will be x √3. Okay, based on 36 and 90. So now I do have a right triangle. I can find the area of this larger triangle in two different ways. The first, just use the leg times leg over 2. So the area, so if I call this is h, area of the ABH, okay, is equal to 1/2 times AH times BH, okay? So that will be just the area, and AH is x √3, and BH is x. That's one way to find the area of the larger triangle. The second way is actually the area of the ABH is equal to area of some of those three triangles. You know, this blue triangle, which is the height is 6, base is 2x. So you can say 6 times 2x over 2. That's that region. And then area of this guy, which is, if I call this is O, B, O, H, is gonna be, the height is 6, base is x over 2. And that's the second one. And the last one is this green region. So this is height and this is base. So I have 6 times x root 3 over 2. So if you add these three, that is actually the area of the larger triangle, which is we already have this guy. So these two quantities has to be same. So let's actually handle those. So this guy is x times x, which is x squared root 3 over 2. And this guy is 12x plus 6x, which is 18x, plus 6x root 3 over 2. So I can cancel these easily. And I can divide both sides by x because x is a positive number. So it's okay to divide by x. So that will be x root 3. And then this is 18. And this is 6 root 3. Okay. So if you divide now by root 3. So if you divide this by root 3. So let's do that. 18 divided by root 3 plus, if you divide this by root 3, that's just 6. And you can just like multiply this fraction by root 3 and divide by root 3, which gives me 18 root 3 divided by 3, which is going to be 6 root 3 and plus 6. And this is our x, but we want to answer the question, which is AB. AB is twice as this. So 2x, which is AB, has to be 12 root 3 plus 12. And that's my answer. So this is one way to do this problem. So I hope that makes sense. So that is one way to look at it. But the second way that I'm going to do, like I can kind of use my similar figure. Actually, let's clear everything. So the second way, I'm going to start with connecting the center with each intersection as well. Let's do this. And if I do the same thing, I want you to just focus on this region for now. So, you know, this is 90 and this is 90 and this is radius and this is also radius, which is, we already know they are 6. Okay. And then, you know, the triangle right here, like if I call this is O, let's say this is H, whatever, T. So BOH and BTO, those two triangles has like side BO as this shared side, and this leg is same on both two triangles. So which is why this triangle and this triangle are going to be actually congruent by hypotenuse leg theorem. Okay, so which makes this guy and this guy is also same. That is interesting. And then we can use a similar reason with the other part. So if I connect this guy right here and do the same reason, you know, this leg is same as this leg, hypotenuse same as itself. So that means this triangle right here and this triangle right here are also congruent. So which is why this piece and this piece will be same. Okay, so now we do know a few stuff, right? So this is 6, this is 6, that is 6. If I call this is A, that will be A as well. And this is B, that will be B as well. Okay. And I do know 30, 60 is still, you know, 30 degrees right here, which means 15 and 15 degrees because these two are identical triangles, so which makes this angle into two equal pieces. But if you look at the larger triangle, opposite side to 30 degrees is A plus 6. Okay. And then if you double this number, I should be getting the hypotenuse, which is A plus B. Okay, so 2A plus 12 is A plus B, subtract A's, A plus 12 is B. Okay, this is something. And then if I use the same thing with the legs, you know, this is my smaller leg, which has to be x to x root 3 ratio in 36 and 90 triangle that we had right there. And if I multiply a plus 6 by root 3, that needs to be b plus 6, because if I multiply the smaller leg by root 3, I do get the larger leg in 36 to 90, which is right here. And I can kind of substitute this into this equation. So let's do that. So b was a plus 2, a plus 12, and plus 6. And that is equal to 8 times this guy will be 8 times root 3 plus 6 root 3, right? And then I do have a's, and I can maybe simplify on both sides. So a root 3 minus a, and subtract 6 root 3 from both sides. So that's 18 minus 6 root 3. And then I can pull a's. Okay, so that would be 8 times root 3 minus 1 equals 18 minus 6 root 3. So if I divide by this expression, so 18, but I can pull the 6 as factor, so it looks like, I guess, helpful. So that will be 6 times 3 minus root 3 over root 3 minus 1. So you can multiply this by root 3 plus 1 to make common, rational denominator, but we don't really need it because this numerator right here actually is similar to this guy. If you see that when I pull this number root 3 out of these two, that will be exactly the same as this one, what's left over, okay? If you don't see, that's okay. Maybe I'm gonna do it in this step. I can write this guy as like 3 minus, let's do this different color. So 3 minus 3 root 3 is actually root 3 times root 3 minus root 3 times 1. So root 3 just root 9, which is 3, and root 3 can be written something like, actually this was root 3. Okay, I'll fix this. So what I'm trying to show you now, just to make it a bit easier for this part. So 3 minus root 3 is root 3 times root 3 minus root 3 times 1, okay? So if I see these guys, which can be pulled, and that would be root 3 and then minus 1. So this guy can be written this way, okay? That's basically what I'm trying to. So now that would be 6 root 3 times root 3 minus 1 over root 3 minus 1. These guys is the same quantity, they will cancel. So a will be 6 root 3. Okay, a is down. So, and then we do know b is a plus 12. So that means b has to be 6 root 3 plus 12. And the question was asking ab, which is a plus b. A is 6 root 3, and b is 6 root 3 plus 12. So which is 12 root 3 plus 12. As you see, this was the same result that we had in our previous solution. So either way, like I'm trying to show you two things. Like appreciate the 36 and 90 first. That's really big deal because we use that in both solution. That's one thing that I need you to keep in mind. And the second, so whenever you have a circle, okay, so let's say I'm gonna use different color. So whenever you have a circle, okay, like this, and you can have a point, let's say outside point. If you connect this to a tangency point, let's actually use this. So let's say this is a tangency point. And let's say this is another one. Okay, I'm gonna make it a bit better looking at least. So let's say this is a tangency point and this is a tangency point on those. So when you connect this center to these each tangency point, you know, these guys are 90, and then if you connect that, so this triangle and this triangle will be identical, which is what we saw right here and right there. So which is why this piece and this piece will be equal. So this is a really important result that we need to remember. That is one thing I want you to remember, and 36 and 90 as well, okay? So I hope that makes sense, and I'll see you in next video, okay? Bye.